Good morning. I don't know why I'm nervous, it's just you guys, but so today I'm just going to take you through a case study on how to improve Brewery Micro. But I think first of all, it's just to give you a bit of background so you can understand where I come from, because I think it's important, because I was just like each and every one of you, So 2010, I got my BSc Honours in Biochemistry. Undergrad, I did molecular and cell biology. Initially, wanted to do pharmacology. Applied at UP. They didn't take me. They rejected me. So reapplied and then got into WITS, did molecular and cell biology, and then eventually did my BSc Honours in Biochemistry. My research was heavily based on HIV, looking at an enzyme and how to mutate it to potentially find a cure. Contrast to that, I'm in the beer industry, very, tricky, but so did that, and then grew an interest in the beer industry, specifically when SAB came to WITS and did a showcase. And I thought, okay, this could be something I could potentially do. So I did my brewing traineeship through SAB. I was based in Newlands Brewery in Cape Town, very beautiful brewery. And it took me about 2 years to complete the traineeship. As part of the traineeship, had to do my IBD. So write all 3 papers in 1 year. Can you believe that? It's crazy. I managed to pass that. And then eventually I got hired at SAB as a yeast and cellulose specialist, looking after yeast health, specifically micro and fermentation. Okay, so I did that for a couple of years until I then moved to Heineken. Heineken, I grew a bit of a passion for training, learning, and development. So I went in as a capability trainer. And my main mandate there was to start developing an in-service trainee program for the VUT students. Where are my VUT guys? Yay, woohoo, okay. For the VUT students, because there was a bit of a gap there with students not getting to do their in-service traineeship. So I initiated that program. It was very successful. To date, we've managed to hire about 20 in-service trainees at Heineken through the program. Then after capability trainer, because I was supporting quality quite a bit, I grew to like it. I grew to be passionate about quality, specifically the taste part of it. Good job. So I was approached to actually become the quality lab lead. So I was managing all the labs at Heineken Brewery. Really enjoyed my time there, managing the micro lab, the sensory lab, and the CTA lab. Learned a lot. And now I am the quality manager at CDBA. So quite an extensive journey, I must say, but I think through everything, I discovered that I'm very passionate about putting the consumer at the heart of everything we do. So maybe that's a lesson you guys can take with you as well. Okay, so I'm going to try to go through this. It's a bit technical, so please bear with me. So it's a case study specifically on Sidibeng Brewery. As you can see, that's our beautiful brewery over there. If you look just behind that Amstel banner, you've got your silo block. So that's where we offload the malt. You can see the trucks over there, right? So we offload about 10 trucks per day. Yeah, so quite a lot of malt that we offload on a daily basis. All our malt is imported. So we don't produce any malt locally because, our SAB people over there, but let me not. And then if you look on the other side, my far right, that is our utilities area. So that's where we generate CO2, or rather clean our CO2. We've got air compressors. We've got our water processing plant there as well. We've got our boilers there as well. So that's the utilities plant. And then if you look behind that utilities plant, that's the packaging hall. So that's where all our lines are. We've got 7 lines and 1 keg line, right? 2 are non-returnable, and then the rest returnable bottling lines. Yeah, so your 650s, 660s, 750s. Yeah. And then there at the back is the warehouse. And then if you come around, that's your BBT and fermentation cellar area. Yeah. So quite a big brewery, capacity-wise, about 7 million hectoliters per year that we produce. Yeah. Cool. Okay, so for my presentation, I'm just going to give you a bit of background. The idea is to give you some sort of methodology around how do you solve problems. So you have a problem that you don't know how to solve. How do you apply a certain method to be able to solve that problem? Then I'll show you, as a result of us following that methodology, what was the result and what were the key learnings. Okay. Okay, so this is based on micro, right? So we have a measure called FTR micro, which is our first time right micro. And what we do there is we look at, do you have microorganisms in your wort, in your fermentation and storage tanks, in your BBTs, and finally in your finished product, right? So we measure that on a daily, weekly, and monthly basis. Okay? So if you look at that graph, it doesn't look good, right? It's showing a downward trend in terms of micro. So it says we have a micro issue. Okay, so this is results that we had in 2022. As you can see, Jan, we were trending in the higher 80s, and then we started seeing a dip in our micro. What that meant is product quality was compromised, right? We have a keg line, so that's a big risk. Why do you think that's a big risk? Why is a keg line a big risk? Does anyone know? Flash pasteurization. So you can't afford to have micro in the product. It meant our microbiologists were working overload because you have to reanalyze, do surveys, and the focus is then obviously not clear. We had a lot of block stock, which if you look at that table shows you the financial impact of blocking stock. So overall, if you look at the monthly average, the cost price is that 969. Right? So it was a major issue that we needed to actually look at and solve the problem. So what did we do? We said, okay, we've got this KPI, it's the one in red, it's not trending in the right direction. So we need to come up with a project plan, right? And as part of the project plan, we need to do something called unified problem solving. So the idea around that is the first thing you do is you define the problem. So what is your problem? Okay, so if you look at number 3 over there, I don't know if you can see it. So what is your problem? And then understand how should the system work, right? And then go back and check, is it working according to how it should be working? So if you're saying a mash tun works this way, so temperature must be at this level, time must be this much, is it doing what it's supposed to be doing, right? Then you go and you do a root cause analysis. So if the temperature is not 60 minutes, why is it not 60 minutes? There's a failure on a valve, I don't know. Why is there a failure? So you follow the process, but I'll take you through that as well. Then once you've defined what the root cause is, you then say, what are the countermeasures to close it? So what solution am I going to come up with to ensure the problem never comes back again, right? And then, as part of the process, you also need a multidisciplinary team, okay? So you can imagine we work for a big brewery, you've got a whole lot of departments, but everyone is impacted by this number. So we had the engineering guys as part of this problem solving. Diversey is our cleaning company, which manages our CIPs. You know what CIPs are, right? Yes. Quality, obviously, key to the process. The brewing operators, as well as packaging operators, and then our cleaning company as well. Okay. So remember I said first step is define your problem. So in this step, you'd follow the 5W1H approach. I don't know if anyone knows or wants to take a stab at what that is. 5W1H. What? What is the problem? Why? Why are you seeing this problem? Where are you seeing the problem, experiencing it? When, yes. Who? So who observes the problem, right? In the ages, yeah, so how do you know that it is a problem? And I showed you that in the previous slide. The results are showing you it's a problem. Okay, so as part of the 5W1H, what we did was we mapped out the process. So you'll see the process there. You've got your brew house, you've got wort cooling, you aerate, you add yeast, you store the yeast, sometimes you propagate, then you go, depending if it's a Heineken or a normal beer, into a horup, then an FST, and then follows the filtration and packaging process. So if you look at that map in red, you could see where the points of contamination were. Okay. And if you knew where the points of contamination were, you could then dive deeper into those points of contamination and say, what are you actually seeing in those areas? So if you look at number 2, we were seeing that a lot of infection we were getting was at our horups. You can see that, right? Okay. And it was mainly aerobic microorganisms. Anyone know what an aerobic microorganism is? It's what? Mm-hmm. Yeah, I'm hearing. Okay. So it is optimal or survives in areas where there's high oxygen levels, right? So ideally, in your upstream process or your wort processing where you add oxygen, you would get some aerobic microorganisms. But eventually they would die off because you go into anaerobic phase, right? Yes. Then in our BBTs, bright beer tanks, we were seeing a bit of anaerobics in there, right? So obviously BBTs, high level of CO2, shouldn't have oxygen ideally. So we're seeing a high level of that in our BBTs. So then we looked at where's our highest level of contamination and then said what microorganisms are we actually seeing there. So if you look at that, we were getting Acetobacter, wild yeast, Lactobacillus, Enterobacter. Okay, so quite a wide range of microorganisms, but the highest probably wild yeast and Acetobacter. Okay, so now we understand the problem. This is the problem we're facing. This is what we're going to tackle. Sorry. Stuck. Apologies. Okay, it's not moving. Can I get some IT assistance? I don't know what's happening. That. Oh, should I use the mouse? Stuck. Ah, there you go. Thank you. Okay, so we've defined the problem. Now I said you need to understand how the process is supposed to work and define if it's in basic condition or not. So that's what we did next. So when we looked at the lab structure, we realized it wasn't in basic condition because we didn't have clear roles and responsibilities within the lab environment. So people were kind of working as and when they were working. So one of the things we did was look at how do you then define clearly the roles and responsibilities for each member of the lab. The second one was around governance, right? So there are certain processes that need to be in place in the lab that you need to execute to ensure that the results that you are giving to the plant are correct. Otherwise, they react to something that's actually might not be there. So we worked a lot on the governance system as well. And then the third one is a sampling point. So if you look at that picture, it doesn't look very appealing, right? So you can see there's some liquid left in that tray over there, and then there's a bit of that silicone tubing, there's some stuff stuck in there. So you can imagine if you've got something like that on your sampling point and you need to go sample, there's a microbiologist, you're bound to get contamination. Okay, so that was not in basic condition. And then key thing is how you prepare your media, right? So we know different microorganisms grow in different media. So if you don't prepare your media well, you could identify something that's not there or vice versa. Okay, so that was also not in basic condition. Then we looked at the CIPs. So this is very key, especially for your lactobacillus, because that's where it thrives. If you're not cleaning your vessels properly, it will grow. So if you look at the first picture, this is what our CIPs were coming out at. So after cleaning, you get that murky substance there. So cleaning was not effective, because ideally what you should have is that last picture. So that last bottle that's clear, literally water, is what you should have. So that told us we weren't cleaning effectively. So basic condition not met. The next one is your HORUP. So remember I said HORUP, we had a high level of microorganisms in there as well. So we opened them up and we found quite a lot of dirt in there. Okay. What was happening there was an installation of the incorrect jetting system for the tank. So it wasn't reaching the entire tank. Okay. So again, not in basic condition. And then there were some CIP changes that were made, which links to the first picture as well. And that is an important point, because in any process when you make a change, you need to test that change first. You don't implement and then just leave it. So that was a result of a CIP change that was made. Okay. We then looked at the hygienic conditions, right? So we have what we call a fermentation and storage cellar. And it's an enclosed environment. So in an enclosed environment, you're going to get a lot of humidity, right? And humidity, bugs love humidity, right? So you need to control that, right? So you need to put a system in place. We call it a vacuum breaker pump. System in place to actually control your set points. They were not in basic condition. So as a result, what would happen, I don't know if I have it on the, yeah. You'd get those wet patches. You see those wet patches there on the floor? Because it wasn't a controlled environment. Okay. Secondly, still, sample point conditions were really dismal. And then we looked at the general hygiene and cleanliness. And we said, okay, where are the hot spots? And when we went there and walked, we saw, okay, there are spots that we're actually missing in terms of a cleaning point of view. Okay, so not in basic condition. And then we looked at our propagation process. So if you look at that picture there with the square, those squiggly bits and those valves there, that's actually a line that we would remove in order to clean it, because it didn't have the capability to do a CIP. So we'd remove it, soak it somewhere, put it back. But that wasn't very effective, because you're not getting the mechanical action through that system. So every time we'd propagate, we'd get contamination. And when you propagate and you get contamination, you pass it on into the next fermentation vessel, BVT, finished product, etc. Okay. So we did the restore basic conditions check. We found a couple of things and we said, okay, what are the root causes? Number one, as I explained, the hygienic conditions. Okay. Number two, the media we were using was incorrect. Number three, the CIP, as I showed you, was ineffective. 4 was the yeast propagation process, not being able to clean properly. And then 5, what would happen was, if we would run say you run a positive fermentation storage tank, you filter it to a BBT, that BBT will be positive, guaranteed. So obviously we were carrying through that contamination throughout the process. So that was the other root cause. Last one, I promise. I see this guy is yawning over here. Countermeasures and standardization. So remember I said, once you find the root cause, you come up with countermeasures. What are the actions you're going to take to ensure it doesn't come back again? So for hygienic conditions, I'm not going to go through everything, guys, because a lot of it is very technical. But obviously come up with a system that will ensure that your hygienic conditions are in place. right? Whether it's a communication system, it's a checklist that you do, you audit the plant, whatever it is. So we came up with that system. We were very aggressive around governance in the lab, because that's where everything starts, right? If the result is incorrect, then it will navigate us to the wrong direction. Then we looked at our yeast management. So obviously, if you propagate yeast, that's positive. It's going to carry through in the process. If you have a positive fermentation tank, you don't reharvest that yeast into another tank. You discard it. So those are the systems we put in place to ensure that we don't carry the infection through to the next processes. Okay, and then we looked at the yeast propagation. So there, we managed to actually build a system that can actually CIP those lines I showed you. So now we are seeing no micro in our yeast propagation process. And then looked at how do you eliminate cross-contamination across the filter, right? So if you run a positive tank, CIP before you run a clean tank, okay? Yeah, and then those are some of our long-term actions that we also wanted to take there, okay? So the next slide is the results. So remember that first graph I showed you, which was 2022, which is that red block with the sad face. That's where we were trending. And this is where we are in 2023. So September, 97% in control. And if you look at that graph, it's very consistent. So it shows that whatever countermeasures we put in place are working in our process. I expected a clap for the 97. What? That was good. I was waiting for that. Okay. So, key learnings from this or takeouts is obviously how do you eat an elephant one bite at a time? So you saw the process is literally one step at a time. So you tackle one issue at a time to actually deal with the problem. Okay. Second one is the power of a multidisciplinary team, right? So don't take that for granted. You might have scientists in your team, engineers in your team, etc. It's very powerful to collaborate and come up with solutions and countermeasures to help solve your issues. Okay. The last one is ensuring you follow the standards. Okay. And then fourth one, be more proactive. So do your CIPs, do your hygiene checks, do your cleaning, check your micro, those type of things, so that you don't have to catch it at the end of the process and now have to go back and solve the problem. And that is it. Quality, no debate. Okay.
Thank you very much. Do we have any questions?
Questions?
Hi, Sissy. I don't know if you can hear me. But as a quality manager, yeah, as a quality manager, like how does the quality assurance work? Do you have like a range of acceptable standard, or it's just specific? For example, if it's like goes from 1 to 5, that's what you can accept, or you just want 3.
Yeah, you are making sense. So I think with quality, what we tend to say is quality, no debate, right? You want it at 3 and 3 is it. But you also have to be reasonable in terms of your process capability, right? So you would then say, okay, this is my target, but my upper range is this, my lower range is this. And then you have that tolerance limit. If you go outside of it, then it becomes a problem. So you do allow variability in the process, but not too much, so that you account for the capability of your process. Yeah.
Because I think sometimes your beer doesn't taste the same for me. Yeah, Heineken, yes, Heineken. So I think it's not a huge difference, but I've noticed that sometimes it's like it tastes different sometimes.
I'll go check the quality sheets on that day. Give me the batch number. I'll check it. Okay, I'll note it.
Good. Okay. Good morning. Thank you for the case study.
So I wanted to ask, you mentioned that during the yeast propagation, you started noticing that there was contamination of the yeast. So had you changed the system so that the CIP wasn't thorough, or what? Had there been any changes to the system? Because I'm assuming that if you had been using the same system, there might have been contamination that you had not been noticing before already. So did you change the system, or what really happened?
Yeah, actually, what I forgot to mention there was what we started seeing is we would have back pressure into that system. So you'd get wort going back in the system. So you clean, right? Take out the stuff, put it back in, and then you get, when you put the wort in, you get back pressure, goes into the system, and then that sits in there, right? And then you can't take it out again because now you're contaminating the entire process. So that's why we said we need to build capability on the inline so that you don't have to remove the pipe. So in a case where you get things like back pressure, etc., you can actually just clean the line without having to remove it and start the process again, because it wasn't very efficient. Yeah, good call out. Thanks.
Yes, you spoke about tolerances, and so even though in that January to September period it was sort of, I suppose, below spec for what you want, was it bad enough to affect the quality that then you had to actually discard a huge amount of beer? Because you obviously, it's not as if you weren't producing for the whole of Jan to September when you knew there was maybe an issue, but was it still within that tolerance range that it was still an acceptable end product? It was just you obviously trying to up the standard.
Yeah, so on a global front, the tolerance would be your 70%, right? But if we are honest with ourselves, I don't think you want to compromise when it comes to micro, because anything can then happen. If your pasteurizer fails and that goes into your finished product somehow, because that's our saving grace, right? You can run at 70% because you're going to pasteurize. But if that fails and that product goes to market, potential recall for us, you know? So that's why we agreed internally to say we should strive for a higher number in terms of our FTR micro, because then we know we're comfortable. Then we know we can focus on other things. Then we know, even when it comes to like CIPs, because that's another drive, then we don't have to clean as often because we've proven, you know, sustainability. We can reduce the times, we can save water, we can spend less on detergents, you know? So that's the ultimate goal, is to get to a point where we don't have to worry about micro. And if we run in the 70s, I can tell you now, if the guys say pasteurization was low, I'm going to be panicking, because potentially that finished product is out there and it's contaminated. So yeah, I think when it comes to micro, rather aim for 100%. Yeah.
Cool. Thank you very
Cool.
much.
Happy. Thank you very much, guys. We appreciate it. Thank you.